Okay, so we've talked about how A affects the graph, all right? That's going to affect our max and our min and also any reflections, all right? D is the sinusoidal axis. That's going to shift our graph up and down. B is going to stretch our graph, wider or more narrower, so left and right. It's going to affect our period. Now let's talk about C. All right, C is going to affect our starting point. And I use the term starting point loosely because it's kind of, it's not really, there really is no start or end to a trig function, especially like sine and cosine. Their domains are all real numbers. So you can really start anywhere, but it's usually good to start close to the y-axis, just, for practical reasons. So the way we're going to find our starting point is to take the expression inside the parentheses, inside the trig function, and set it equal to 0, right? Because we want to figure out what value of x makes us take the sine of 0, or the cosine of 0. Because remember, sine and cosine, what you plug in are angles. And the easiest angle to start at is 0, 0 radians, 0 degrees, because that's a nice point on the unit circle, all right? So now we're going to put it all together. And let's start off with our starting point. So for graphing this example here, y equals 4 times the cosine of 3x over 2 minus 3 pi over 8. We're going to take 3x over 2 minus 3 pi over 8, set it equal to 0, and solve. Okay. Now remember that x is the only variable in this equation. Okay. Pi is not a variable. Pi is a constant. So we're going to leave our answer in terms of pi. Okay, so I'm going to start off by adding 3 pi over 8 to both sides. Okay, then we have a fraction set equal to a fraction, so we could cross multiply here. Get 24x is equal to 6 pi. Okay, then divide both sides by 24, and we get that x is equal to pi over 4. Alright, so that's going to be our starting point. So I'm going to write that up here. Starting point is going to be at x equals pi over 4. Okay. Now everything else we're going to kind of go about in a similar way, except when we get to the increment, we're going to do something different, slightly different, because our starting point is no longer at 0. All right. So there's our x and y axis. Okay, so there's no shift up or down, so our y axis is also going to, our x axis is also going to be our sinusoidal axis. All right, now that's the y axis, this is the x axis, and the x axis is also known as y equals 0. All right, now so our maximum is going to be at 4, our minimum is going to be at -4. Okay, so we got D taken care of, we got A taken care of, we got C taken care of. Now we have to use B to find our period. Alright, so period is always going to be 2 pi divided by B. Alright, B in this case would be 3/2, 3 over 2. Okay, now you could do keep, change, flip, so do like 2 pi divided by, so keep the 2 pi, change the divided by to a multiply, and then flip the 3 over 2 to a 2/3, and we get 4 pi over 3 is our period. Okay, which means our increment is going to be 1/4 of that. So if we take 4 pi over 3 and then divide it by 4, that's the same thing as multiplying it by 1/4. We get that our increment is pi over 3. Okay. So one thing that I like to do after I find my increment and my starting point is to get a common denominator. So if my starting point is at pi over 4 and my increment is at pi over 3, what I'm going to do is write both of them with a denominator of 12, because that's the least common multiple of 4 and 3. So I get this is 3 pi over 12, and pi over 3 is going to be 4 pi over 12. Okay. So now what that allows me to do is I could start here at 3 pi over 12. That's my starting point. And then every 4 pi over 12, I'm going to plot another point. Now the reason why I got a common denominator is it makes it a whole lot easier to add these. So like 3 pi over 12 plus 4 pi over 12 is going to be 7 pi over 12. All right, and then add 4 pi over 12 again. So that's going to be 11 pi over 12. All right, add 4 pi over 12 to that. So that's going to be 15 pi over 12. So we need one more point to make 4 intervals. So that'll be 19 pi over 12. So now we got our 5 points. All right, and it's cosine that we're dealing with. So for cosine, we're going to start at the maximum and then go to the middle, back to the minimum, back to the middle, and then back to the top. All right, and that's how you graph by shifting these left and right. So quick recap, we're going to take what's inside the trig function, set it equal to 0, and then solve. And then once you find your increment, get a common denominator between your starting point and your increment, and then make whatever the starting point is, that's where you want to put first on your x-axis, and then just add the increment to that 5 times or 4 times, 4 more times. And then plot your points just like usual.